In the previous video, we talked about arithmetical operators, and in this video, we are going to talk about relational operators and logical operators. So let's get into it. Let's first talk about relational operators. These operators either return true, which is represented with 1, or false, which is represented with 0. And as always, to use these operators, we need variables. So let's first declare two variables. And we also need another variable that will store the result. And as these operators are going to return either true or false, and true is represented with 1 and false is represented with 0. So 1 and 0 both are integers, and that's why I have declared this result variable as integer. So the first relational operator that we are going to talk about is equal to operator. We are going to need two variables for this operator. So this is the first variable, and this operator, this is equal to operator, is represented in C with double assignment symbols, and there is no space between the two. After that, we write our second variable and then terminate. So what this operator is going to do is that it is going to compare the values of both the variables. So in our case, it's going to compare 3 with 2, and it's going to compare to see if they are equal. So it's going to see if 3 is equal to 2, and as we know 3 is not equal to 2, so this operator is going to return in this case 0. And as we talked about, 0 represents false, so this here means that no, they are not equal. That's why it returns false. And to display the value of this result variable, we do that with the printf function. Now if I run this, okay, so we have a typo. Now if I run this, you see we get an output of 0 as expected. Now if I change this to, let's say, 3, if I run this, it should output as 1 because both values are same. As you can see, it prints 1. Next, we are going to talk about another relational operator known as is not equal to. So if I change this to an exclamation mark, now this becomes an is not equal to operator, and this is an opposite of is equal to operator. So with is equal to operator, we were able to check if two numbers are equal or not, while as with is not equal to operator, we check to see if both the variables are not equal to each other. So in this case, if I say 3, 3, this should return as 0, which means false, because 3, it says 3 is not equal to 3, but as we know 3 is equal to 3, so this should return 0. Now if I run this, you see as output 0. Similarly, if I change this back to 2, and now if I run this, you see 1. Let's keep moving on to our next relational operator, and that is greater than. It's represented by this. This, as the name suggests, it's going to check if the value this variable is holding is greater than the value this variable is holding. So in our case 3 is greater than 2, so this should return an output of 1, which is true. So if I run this, you see an output of 1. This, let's say 1, this gives an output of 0, which means this number 1 is not greater than number 2. What if I change this to 2? What do you think the output would be? Is 2 greater than 2? No, it's not, right? This should give me an output of 0, as you can see, as expected. Similarly, we have another operator, relational operator, which is less than, which is an opposite of greater than. So if I change this to 3, so is 3 less than 2? No, it's not, right? So this is going to give me a 0. So if I run this, you see a value of 0. Similarly, if I change this, let's say 1, now if I run this, it should give me an output of 1, which means true. As you can see, the output as expected. And moving on to our another relational operator. So the next relational operator is greater than equal to. So this is kind of combination of two operators. So this greater than first checks if the value of this variable is greater than this variable. If it does not meet the condition, if it returns false, then it's going to check if the two values of the variables are equal with this equal to operator. So in this case, the first variable is holding 1 and the second is holding 2. So with this greater than operator, it's first going to check if 1 is greater than 2, and we know that 1 is not greater than 2. So then it's going to check the equal to operator. Is 1 equal to 2? No. So this in whole is going to return false. So if I run this program, you see 0 as output as expected. Now if I change this to, let's say, 2. In this case, it's going to check if 2 is greater than 2, and we know that 2 is not greater than 2. So then it's going to check if they are equal, and yes, they are equal. So this whole statement is going to return true, and that is 1. So if I run this, you see a value of 1. You have to understand that this greater than equal to operator is different than greater than operator. In the sense, in case of greater than operator, if the two value of the variables are same, this whole statement is going to return false. But in case of greater than equal to operator, if values of the variable are same, this whole statement is going to return not false but true because of this equal to operator. And the last relational operator is, as you have guessed, less than equal to. This less than equal to is opposite of greater than equal to. So this is going to check if the value of this variable is less than this variable, and if this is not less than this, then it's going to check if they are equal. So if I say 3 is less than 2, is 3 less than 2? No, it's not, right? Then it's going to check if it is equal, and they're also not equal. This whole statement is going to return false. So if I run this, you see false. In the same way, we have another group of operators known as logical operators. And the first logical operator that we are going to talk about is AND operator, which is represented in C with double AND symbol. If you are wondering why I am using these two double AND signs to represent an AND operation, why can't I use a single AND operation? The reason behind this is that single AND itself represents a different operator, and we will talk about that in the upcoming videos. Now these logical operators, instead of taking operand as variables, they take operand as an expression. So this is an expression. So this AND operator is going to take operands as expressions. So let's make it a little bit easier. So if I group this expression in brackets, And if I copy this and place it as other operand of this AND operator, so let's see, I change this to is not equal to. So this AND works like this. If both of the expressions return true, then AND is also going to return true. While as if one of the two or both the expressions return false, then this AND is going to return false. In this case, if we see that this expression number 1 greater than number 2, so 3 is greater than 2, so this expression is going to yield true. Similarly, this expression is also going to yield true because it says 3 is not equal to 2, and in fact 3 is not equal to 2, so this is also going to return true. So when AND encounters true from its both the expressions, it yields a return value of true. So if I run this program, it should return true. As you can see, it returns true, which is presented with 1. If I change this to 2, for example, what do you think the output of this AND operator would be? So let's see. This expression is going to return false because 2 is not equal to 2. Recall that we said an AND operator is going to return false if one of the two expressions return false. In this case, the first expression returns false, so this AND operator does not have to evaluate the next expression. It does not have to check the return value of this next expression. And this phenomena is known as short circuit. Let me repeat it one more time. An AND operator is going to return false if one of the two expressions return false. And in this case, the first expression returns false. So it does not matter what the next expression is going to return, because by definition, an AND operator returns false if one of the two expressions return false. So it concludes without having to evaluate the next expression. And this phenomena is known as short circuit. So short circuit simply means to return a result without having to evaluate all the expressions. So if I run this, it should return a value of 0. So if I run this, you see a value of 0, which means false. Now let's move on to our next logical operator, and that's known as OR, and it is presented with these two straight lines. So how this OR operator works is that it checks to see if one of the two expressions or both the expressions return true, then this OR operator is going to return true. Otherwise, if both the expressions return false, then this OR operator is going to return false. So in this example, this expression in our case is going to return false, and then this expression is also going to return false because 2 is in fact equal to 2, but it's saying not equal to. So this expression is also going to return false, and an OR operator at last is going to return false. Let's try it. So if I run this, you see a value of 0 as expected. Now if I change this to, let's say, 3, first this expression is going to turn as true because 3 is in fact greater than 2. So this OR operator does not have to evaluate the next expression because it gets the first expression as true, and by definition the OR operator is going to return true if one of the two. So in this case, it's also going to follow the short circuit phenomena. So it's going to conclude without evaluating this expression. And if I run it, you see the output as expected. Now let's talk about the last logical operator, and it is the simplest of all, and it's known as NOT operator. So if I say number 1, and it's presented by this exclamation mark. So if I have this condition, let's say, now as you can see, this expression, this condition is going to return value false because 3 is not equal to 2. So what this NOT operator is going to do, after this expression returns false in our case, this NOT operator is going to convert that false to true. So this NOT operator simply inverts If it gets true, it inverts that to false. If it gets false, it inverts that to true. And that's all what this not operator does. So in this case, this expression returns false. And with this not operator, we change that false to true. So if I run this, you see a value of true. Similarly, if I say I change this to, let's say, is not equal to, this expression in our case is going to return true, right? But because of this not operator, this true is going to be converted into false. So if I run this, you see a value 0 which represents false. With that, we come to an end of this video. And as always, I would like to give you an assignment. You can send your assignment in the email given in the description of this video. Okay, you have to create a program given someone's height and someone's age. By the way, to represent someone's height, you can represent it in fractional number. For example, if someone's height is 5 feet 11 inches, you can represent that as 5.11. Coming back to our question. So given someone's height and age, you have to print 1 if that person's age is greater than 18 and his height is less than 5.6, or his age is less than 10 and height is less than 3. And if you like this video, give it a thumbs up and subscribe. I will see you in the next video. Till then, take care.